Welcome back to the show. I'm here with Jon Clausen. I hope I'm pronouncing that right, Jon.
Clausen, but close enough.
Clausen. Right. All right. And he's the president of Silo WebWorks and a member of the Autis team. And he's going to be speaking into the box. And we're going to talk about Portable CFML with cloud deployments, microservices, and REST. And he's actually giving 2 talks, and he's also giving a whole day workshop. So we're going to talk about all that in this episode. And we're going to start off by looking at platform as a service and how you can save DevOps headaches with smart cloud deployments and different options there are for container-based PaaS solutions. And also we'll look at how you can use microservices to take a monolithic legacy app and cut it up into microservices so that it's more maintainable and portable and scalable. And some clever ways Jon has for overcoming resource-intensive sections of the code in an app so they can scale out separately from the rest of the app. And then also we're going to look at REST architecture and why that works so well and why it has to be stateless. So welcome, Jon.
Thank you.
So let's come back to the beginning of that. You're talking about PaaS, which stands for Platform as a Service. So why would someone, want to use that? And what exactly is it?
Well, Platform as a Service is basically, and it's implemented in different ways across different providers. So you've got your for-pay proprietary providers such as AWS Cloud Services, Google Cloud Services, Heroku. You also have open source options available to you as well. So you have, for example, Dokku, which is basically Heroku, an open source version of Heroku. You have Kubernetes, which is a Google product that is continuing to evolve, and a lot of people are really adopting that. You've got front ends also for Kubernetes as well that allow you to do build packs. There's a product called Days that works with Kubernetes that way. And then you also have Docker Swarm, which is Docker's own native implementation. And what a platform as a service does is it abstracts the whole, the details of the container layers and allows for easy deployments, sometimes scheduling, management, and orchestration of containers across one or more servers. And so what that effectively allows you to do is spend less time dealing with all of the ins and outs of writing Docker files and the DevOps portions of how those are going to be scaled up specifically on a machine-by-machine basis. And usually, in most cases, allows you a single entry point to push your updates, and then the platform as a service takes those and automatically deploys them across the scaled instances that you've specified in your configuration. Platform as a service also allows you, because all of them allow you to inject secrets into your containers as they spool up. And so, things like database passwords and all these other things that at one point we sort of had to keep in the code just because that was the only way we could reliably deploy them. Your platform as a service becomes the holder of those secrets, and then simply injects those as environment variables into the containers so that the containers themselves can be either individually or configured as a whole to use those secrets to connect up to the things that they need to connect to. So the platform as a service model is really valuable for developers. First of all, because it simplifies the whole process of deployment and continuous integration, but it also provides you a very easy way to abstract the whole container infrastructure into something that is digestible and requires fewer touch points in your code, in your application, and from you as a developer in configuring things. So that's kind of an overview of what PASS does. And my workshop is basically going to give an overview of several of those services. Actually, an overview of all of those services and what they do, and then also give some real world examples of deployments on specific ones. So we'll be using Kubernetes, we'll be using Docker Swarm, and we'll be using Dokku, which are three kind of they're different models, and they're models that are different enough that we can kind of show how those work and what are the differences between how they handle things under the hood. So I'm looking forward to that. I think that'll be an exciting work session.
Yeah, it sounds powerful to be able to do that. So for people who aren't deploying ColdFusion in the cloud and aren't even using a container, what exactly is a container? Is it a virtual server, or is it something more than that? Or?
Well, it's easy to think about them like virtual machines or virtual servers, but really what containers do is they provide a self-contained and isolated entity that utilizes the system operating resources to run specific processes. So what they do effectively is they're like virtual machines, but they're not, because they're sharing the resources of the host container. And so Docker is an example of one of the, is certainly something that everyone is familiar with. Those small Docker containers run within a Docker machine, and that Docker machine's environment could be your host, the whole host, or it could be a virtual machine within inside the host. So they're infinitely nestable. They're connectable via a very configured networkings between only specific containers that are allowed to talk to each other. So from a system resource usage standpoint, they're very effective because you can isolate the amount of resources available to the container machine and to the containers. But on the other hand, you have the ability to connect those containers together. Database servers, Memcache, Redis, whatever you're looking for. You can connect all those points together to deploy very easily one single application with all its dependencies. And what it does, is it prevents you from having to configure those at the service layer and then the operating system layer, and then makes everything portable from that point onward. So, containers are becoming very popular mainly because they signify portability, but they also require a bit of a paradigm shift in the way that you think of your applications and how they're run and deployed, and how they're accessed, because they are, they're a Russian nesting doll, and they can be a really deep Russian nesting doll, that goes a long ways down, with a lot of little parts inside. So, it is a paradigm shift for developers, especially CFML developers that have been dealing with these big servers and trying to throw hardware at application problems, because it forces you as a developer to think in terms of segments of your architecture as opposed to the big monolith of your application.
So when you're using the word portable here, are you talking about that you've got your deployment on your own laptop and then you're porting it out into the cloud or onto other servers or to other team members, or is there some other? Yeah. So let's say, for example, just to give an example workflow as a developer, and I'll use Dokku as an example, which is, like I said, it's an open source version of Heroku. Dokku has an interface that works basically just like a Git repository. So if I have a cluster of 3 servers, let's say I want to deploy that my application is deployed to, the process for deploying to all those servers automatically is as simple as git push Dokku master or development master, whatever my branch I'm working on is. So from a continuous integration standpoint, it's really easy because I just write my pipeline file and I loop through all of the instances that I want to deploy to. Git adds those all as remotes that are contained to this Dokku and then just pushes them all. And so each push, it goes to each individual container, and all of those kick off their deployment process. They build and they scale according to the settings. So, one example is, I've got one app that deploys across three different nodes in the cluster that's behind a load balancer. And when that continuous integration build, the pipeline job kicks off when I make a push to the master branch of the repository, it goes and does that. It deploys to all 3 servers automatically because Dokku has abstracted that whole process, the container strategy. And then because I've set it up so that there are 3 instances of that, there are 3 containers on each of those servers that run serving that application, it not only
not only deploys the one instance, but it deploys 3 instances on 3 servers. So I now have 9 instances serving traffic. So I can throw big hardware at it, and I could have 9, 10, 11. I mean, Docker Swarm, they test regularly at 1,000 to 10,000 instances running. And I can have all those set up, but I can scale at the instance level, and I can scale at the server level, and it makes it very portable. Because if I have a problem with one server, I spool up a new machine that knows that language. I add my configuration secrets, and I just start deploying to it and switch the load balancer over to the new server. So I'm not dependent on the hardware. If I have a hardware problem, or if I have a networking problem or something that is going to take me more time than necessary to diagnose, I simply just move it, and I do it very quickly. And that can happen within a period of, within 10 minutes, I can have a new server up and serving traffic and the load balancer pointing at it, which makes that whole DevOps problem that, people who have been doing CFML development for a while, it makes that whole problem go away. So like, let's say, for example, I'm using the CommandBox Docker container on, Docker Swarm. I can self-contain my configuration. I can use secrets on the instance level. I can do all sorts of things that automatically configure that container. And when I pull down that server, let's say I'm using ColdFusion 2016. When I pull down that new version of the ColdFusion 16, it's already patched, and my configuration environment variables automatically inject all the settings I want in there. My data sources, my administrative passwords, caching, debugging, security, sandboxing, all that stuff is being is automatically being injected in the process of building up that container. So I don't have to patch anything. I just restart the application, and it automatically brings, if ColdFusion 2016 has been patched, I automatically just restart the container. It pulls down the newest version of that server if those server files aren't up to date, and it applies the configuration I've specified to them. So from a portability standpoint, that is kind of what I'm talking about. I'm no longer bound to hardware. I am looking at my applications as very portable things that can be deployed on many, many different platforms without, too much difference in configuration between them.
So this not only speeds up deployment, but it also documents what has to be deployed and all the configuration, so you can replicate it out without having to bring in a sysadmin to mess around for a week,
Exactly.
Getting your new server spun up.
Exactly.
Which sounds wonderful. What about, scaling? If you've got an app that has extra demand a certain time of year, or, it just gets a popular viral post and suddenly it's like, using up a lot more demand. Does this help with scaling?
It can. There are some of the platform as a service, the PaaS as services, have the scheduler built in. Some of them you have to automate the scheduling. So, Kubernetes has a great scheduler built into it. Docker Swarm has scheduling built into it, where you can configure it. So those are examples of very powerful systems where, let's say, for example, I've got one client, for example, that runs a big chocolate shop, and they sell lots of chocolate, and it's Easter, and this is their prime time, because everybody's buying their Easter chocolates or whatever. And they need a lot of resources there. So from March 1st to April, I don't know what day Easter falls on this year, but the middle of April, I'm going to want more resources dedicated at that. And I can schedule those to go up, on a date range. I can schedule those to go up on a time frame. So if my peak times that my application is being used are from 9 a.m. to 5 p.m. in my time zone, because my whatever my application is there works on is based in that time zone, I can spool up additional instances to handle traffic during that time frame, and those instances are brought down at the end of that at 5 p.m. or 5:10 or whatever I specify. Those instances are brought back to the baseline of maybe 1 per server. So it really, scaling is really something that you can decide based on what you want to do. and you can kind of take a look at it from there.
What about tying that into monitoring? You know, if you have some monitoring software like Fusion Reactor or some other thing that tells you how much load your server's getting, can it automatically just start spinning up extra instances?
Mm-hmm. Yes, and as a matter of fact, one of the nice things you can do with Fusion Reactor is you can deploy it with CommandBox, and you can connect different nodes up to it. So Fusion Reactor can know about what's going on with different nodes in your instance. So they can register themselves and connect up. And so yes, you can have a very effective server monitoring with Fusion Reactor. You've also got the built-in monitoring that happens because all of those processes are being managed by the platform as a service, the PaaS. And so when those containers go down or they become unresponsive, the containers are simply, brought back, they're restarted or brought back online. And you can set scaling rules. So you can set scaling rules to say, if I hit, the resource uses of this hits this, I scale up one, or I bring down one if all of my servers are at 20% resource usage. And that's specific to whatever type of resource you want to monitor. But yeah, you can do that.
That sounds really powerful and takes away a big headache that people have on their apps that, you have to plan out stuff ahead of time. And it doesn't take away that you need to optimize some of the code. If something's running slow and it's, spitting out tens of servers, you've still got a problem to deal with, but at least it didn't crash the site while you're dealing with it.
Exactly.
So very exciting. So let's move on. You've got a second session that you're teaching called Bringing Legacy Apps Back to Life with Box Microservices, which sounds intriguing and somewhat related to this. So maybe for people who aren't using microservices, what exactly is a microservice?
Well, microservice architecture in its most simplified kind of definition is simply a functional piece of software dedicated to a specific purpose. And so a microservice in the sense of a CFML application would be simply a service, whether it be deployed with the application or in many cases, better yet, separately from the application, that handles the specific functionality of a component of that application. So for example, in most CFML apps, especially legacy CFML apps, they start with a business objective and they develop over time. And what ultimately happens with procedural apps, especially older procedural apps, is over time they develop into these huge monoliths that have tens of thousands of lines of code and many points of duplication. And so as those evolve and become more mature, we're forced to throw resources at them to be able to make sure that these little parts of the application that are resource intensive can run and the rest of the application can also run as well. A microservice is basically taking a component of that application. Early on, what this means in a procedural standpoint is a pain point, maybe a resource intensive pain point in that application, and breaking it out into a smaller component that is delegated with just the responsibility of handling this particular task. And what that does, what you'll find when you develop microservices, and especially when you convert old legacy applications over to a microservices architecture, is that you use fewer resources cumulatively because the amount of resources required to run this smaller service is much lower than the amount of resources required to run it in the monolithic app, simply because we don't need this fail-safe buffer so that if this starts to consume resources too much, it doesn't bring the application down. So you might need 256 megabytes for your microservice, but that same microservice, when deployed in your legacy monolithic app, might require 1 gigabyte just to be safe. And so what that means is, let's take that gigabyte. So that means that I can deploy one microservice with my small component of functionality at 256 megabytes. And if I need more resources allocated at it, going to containers again, I can spool up a container and now I've got 512 megabytes dedicated at it on 2 containers versus, this monolithic app, once again, that needs that gigabyte. And if that monolithic app is scaled, now I'm decreasing that even more. So legacy applications, specifically CFML procedural applications, are ideal candidates to convert over into a microservices architecture, because so often there's so much duplication of code. There's so many different pain points where one little process, if you're not careful, can throttle the application if there's concurrency in different areas that are pain points. And it's easy to do, because once you identify where those are at, those touch points for this functionality are at in the code, you simply break them out, you develop your microservice, and then you go ahead and change the endpoints over in the code to talk to the microservice instead of talking to, to doing its own thing internally. So when we're talking about legacy applications, it's a really viable pattern for eliminating some of those pain points. And what happens over time as you develop each microservice and you deploy them, I mean, your development workflow doesn't have to change that much, because in the sense of being able to use a ColdBox module, that modularity can work within a monolithic ColdBox application or a monolithic application, but it can also be deployed separately as an individual module with its own, endpoint and URL. So it gives you a lot of flexibility to be able to deploy your application in a variety of different ways.
So it's almost like a metaphor for this would be the monolithic app is sort of like you've got a whole football team, and when you want to scale the team, you had to duplicate the team and get a whole nother football field. Whereas with these microservices, you're just duplicating the individual players that are used the most. Mm-hmm. So, maybe you have one player that gets used a lot, but other players aren't. So you don't need to duplicate the whole football pitch and the whole team.
Absolutely.
You just scale up the individual resources that are used a lot.
Absolutely. That's a great analogy.
Yeah. So you mentioned using CodeBox for this. You can do microservices in many different architectures, and Box is only one of the ways of doing that. Why Box for you?
Well, I think there's a couple things. First of all, microservices they're not, like you said, they're not tied to a specific implementation. You can use whatever the best tool is at hand. What I have found in developing in a variety of different languages is that ColdBox and CFML gives me the most rapid time from concept to deployment, and it also gives me a variety of options and more portability with regard to options, because I have the power of being able to leverage all sorts of Java classes to do what I need to do, and there's tons of those out there. But also, the modularity of ColdBox means that if I deploy, all I have to do is commit one module to my repository and a configuration file, and with a well-written Box JSON file, I can deploy that application with one install command anywhere I want to do it. So it makes it, tremendously powerful in the sense that I have the modularity of ColdBox and the universality of that code across a variety of things makes it very easy for me to develop a small service, but also to take and build a service into an existing application, and then, if necessary, break that service out at a later date. And that's really the power of modularity. So often when we end up with these monoliths of code that over time it grows and grows and it becomes super intimidating to actually even do anything with, because you're afraid if you touch that one, that one line and that one piece of the shared code or whatever you want to call it, you're going to blow up a whole bunch of other things. And modularity prevents that from happening, because you can build modules and you can version modules if you want to, so that your code can be dependent on a specific version. And ColdBox, because it's built from the ground up with that modularity in mind, makes development extremely rapid. It makes all the process of routing URLs and handling routes and dealing with system configurations and all that. It makes it just super easy. So I don't have to spend any time worrying about that in development, and I don't have to spend a whole bunch of time building the architecture around that. I simply I have the architecture and I have the patterns and the conventions already there for me. I build within those, and it means that I can deploy things that are bug-free and scalable and fast, much faster than someone in a variety of different other languages. There's, like I said, there's a lot of people that have, very justifiable beefs with what CFML was and what they see it having been throughout its history. But the reality of it is it's never been more portable than it is now. And it's never been easier to rapidly develop applications and scaffold applications and test applications than it is today. And ColdBox is a big part of that. I was pretty much ready to get out of the CFML game a few years ago, more than a few now, but and then I picked up an application that required me to use CFML, and I looked for the best candidate, the best framework to convert that legacy application over, and ColdBox won, and that renewed my excitement about CFML development and about being able to continue to work in this language and build relevant applications for the future.
I think you've answered my next question, Jon. You must have had a predictive cache running, which is why are you proud to use ColdFusion?
Yeah, and that really sums it up. I feel like when it really comes down to it, and I'm making an architectural decision on an application, CFML gives me the best opportunity to develop the most efficient, bug-free, and scalable application, with the caveat on efficiency being that it does run on top of the Java virtual machine, and you've got the resources that requires, but there's so much power in being able to leverage the underlying engine in addition to the language, the expressiveness, and the power of the language itself. Having done development in other languages, you just don't have the same, the convenience of all of those built-in methods, and then you add ColdBox on top of it, and you've got all these other conventions and super type methods you can leverage. With other languages, you find yourself reinventing the wheel over and over and over again to solve problems that were already solved in CFML many, many years ago. And so for me, it's like, okay, well, let's find the language that gives me the best toolkit to start out with, the biggest toolbox to work with. And if I have all of those tools and I have them readily available and conveniently assembled, then it makes it so much easier for me to quickly build and deploy powerful and bug-free applications. So that's why I'm excited about CFML, and I really continue to be, because I think a lot of times the CFML development community can be its own worst enemy, because we don't spend enough time honing and looking at, okay, how we've done it this way for so many years, how can we do things differently? Or we're stuck in the Java development model, and we want to do things like Java does them, and we totally neglect the power of our loosely typed language in rapid application development, and how powerful it is in abstracting and scaffolding applications very quickly. So those are things that I think are out there, and there's certainly issues as we go forward. But I think CFML has never been more portable. It's never required fewer resources to run. For example, the ColdBox CMS content box. I can run a content box instance very comfortably, day in and day out on 256 megabytes of memory. Now, when was the last time that we, when we're talking about the monolithic stuff, when was the last time where we had, CFML deployments being comfortable on that small of a heap size? It's become much more portable, and it's much more realistic to be able to deploy smaller and smaller resources on commodity hardware. That just wasn't really an option,
I was
5 years ago.
I was talking to Brad Wood the other day, and he said he deployed a CFML app to a Raspberry Pi computer, yes. And I don't think they have a lot of resources on them. They only cost a few bucks.
No, his application, his blog runs on that Raspberry Pi, and he's actually he's tested it pretty hard and done a lot of load testing on it. So yeah, it's very doable.
He even had it he had a separate Raspberry Pi computer tied up to some LEDs in a hat he was wearing at a conference. So
yes.
Yeah. So amazing what you can do there. So, I mean, I think all this Codebox and all, the PaaS and all the other things help us be more modern in our ColdFusion, and they help bring ColdFusion back to its full aliveness that maybe it lost a few years ago. Yeah. But I just want to ask you, what would it take to have ColdFusion be even more alive this year?
I think that's a good question. I think what we have to do is we have to talk it up. We got to stop being scared of bringing up CFML in the larger IT communities. I mean, everything's going to have its haters. Every language is going to have its haters. And but I think when you really, at the end of the day, most developers, no matter what language they want to get their job done as easily and as pain-free as possible. And day in and day out, I will take CFML for that. And that's been my preference. And like I said, I've forayed out into others and spent enough time to know that, if I'm going to have an option to pick the language I want to develop in, CFML is going to be right up there for 90% of the things. And now with CommandBox and all the the container-based strategies, it's mind-boggling how much easier it is than it was even 10 years ago. And I've been a CFML developer now for 16 years. So
cool. So I know also, as well as teaching 2 sessions, you've got a whole one-day workshop on REST. Mm-hmm. So let's talk a little bit about that before we wrap up here. Mm-hmm. So what exactly is REST for people who aren't doing it?
Well, REST stands for Representational Stateless Transfer, and it is probably more and more the most prevalent API architectural pattern that we use. And effectively, if you're familiar, let's just to kind of give you a sort of an example of what that entails. In the acronym, representational effectively means that your returned objects represent other objects within your data model, okay? So in most cases, that means you're dealing with sort of an active entity pattern in your REST application. And so when you return the object, you're returning the entity or the representation of that object in the way that you've marshaled it as, a data object, whether that be XML or JSON. We often think about it as JSON, but it can be the data pattern and how you deliver the data doesn't really matter. It's not defined by REST. Most often it's just JSON. So that's the representational part. The stateless part means that every request requires authentication. It means that we don't set cookies, we don't keep session variables. And what that does, the benefit of that is that it makes your API portable by being able to deploy it anywhere and not being dependent on browsers, on users, on capabilities of the client. And so that's where statelessness comes in. And then the transfer state is simply the fact that this is a marshaled representation. This is not a direct representation like you would get if you were running a query. This is a marshaled representation of how you want to produce and consume, ultimately will consume that object, that representation. So it's, the transfer pattern that is most often used is HTTP, but REST services can also be consumed in a variety of other ways. So they're often, in many cases, we're starting to see a lot of binary applications that have their own RESTful service built in, where internal calls are being made and those RESTful representations of that are being delivered. But most often it's HTTP. And because of the way that REST is evolved, it makes full use of the language, the HTTP protocols, with regard to the status codes and what they mean and how we're delivering responses to the client, saying what we've done or where the error was or what kind of error it was. And that's, RESTful services are basically built around the concept of this very expressive, very verbose protocol that up until now, we really haven't had much dialogue about taking advantage of. Because none of the stuff that REST does as far as the protocols are concerned and the HTTP protocol is concerned is anything new. I mean, it's been around many, many years, but at the same time, we're leveraging that to deliver that representational state to many, many clients who can consume it with different purposes in mind, and that works just as well for internal as it does for external consumption. So.
And is this another way to get duplication out of legacy code by rewriting it as a REST architecture?
Yes, this is absolutely RESTful design. If one of the three pieces that I'm speaking to at Into the Box this year are really interrelated, and they're all addressing the criticism and concern of portability. And RESTful services is an ideal way that you could implement a microservice, for example, as we've already talked about. It's also a way that you can implement a data model within your application that can be consumed by many different layers, including the browser, the client side, but also within the application. Because if I develop a RESTful service, all I need to do from within my application to be able to retrieve that marshaled data is know what my RESTful service needs for parameters, and then simply run the event that is in my API to marshal those parameters into my in ColdBox language, my request context. So yes, it's absolutely a way to develop microservices to convert legacy applications over, because they, in many cases, like I said, you're spending all this time marshaling and reusing or rewriting the ways to develop this. And think about all these different variations in legacy applications of the same query with different columns being selected, or maybe an SQL function in there to marshal columns in a particular way or in a particular format. And RESTful services are designed to do that. They're designed to allow a consistent representation that requires very little duplication of code, because they are the single endpoint that we use to gather this marshaled data.
So what about if you have different versions of the API that you've got? That's
a great question. So we one of the things that RESTful services allow you to do is version them very easily. And there's many different patterns to do that, but as you evolve, your API evolves. One of the core concepts of REST design is never breaking backward compatibility, or if you do, be very clear on when that happens. But most of the time, we're not breaking backward compatibility. So if I release version 1 of my API, when that version is released, that version is never going to change. I then version that to version 2, and new endpoints I communicate, they can start talking to version 2 when I deploy that and release that, but I'm not breaking the backward compatibility for any of the consumers, because API version 1 is always going to be available. And ColdBox modularity makes that super easy to do, because I can very easily version modules. I can, set my endpoints up, and almost always when I'm building a RESTful service, I'm actually building the versioning into it right from the start, rather than going back and adding that later. So very rarely will I have a route that's just API. It's going to be API v1 entity name, as opposed to having just a API route.
So the other thing about REST is, you can easily connect it together with CommandBox and CodeBox. How are you using those together? They fit well together.
They do. There's actually a RESTful application template that's out there. It's the ColdBox REST template. So a lot of times a new API is going to start just by pulling that template as my skeleton for my ColdBox application, and then from there leveraging the pieces that are part of that. It also works extremely well because you have all sorts of interception points that are built into ColdBox that you can use to handle consistent data marshaling. So for example, if you go and you check out the REST template, the REST skeleton, you'll see that there are a couple conventions in play. One is the around handler method, which basically runs around whatever your execution event is. And that around handler method in the RESTful template handles all of the process of marshaling data, handling errors, communicating those errors in a consistent format that's easily consumable. In addition to having some convenience methods for common responses, such as not found, not authorized, all those things like that, that you can leverage right off the bat. So it makes it very easy to develop those because you've got so many kind of hooks and interception points that are already built into the framework that allow you to quickly build them out. And it's not unusual to have a fully functional CRUD REST entity that is less than 100 lines of code. Because, you know, with the tools that are available out there, there's a lot fewer lines that need to be written to deal with those sort of procedures and conditions.
So folks coming to this one-day workshop on REST, are they going to be able to code this themselves, or are they just watching you create it, or
nope,
which is it?
Absolutely. We're going to spend, by the end of the day, the goal is that the user walks out with a fully functional API, which they have developed themselves, which solves a common business problem. And we'll have some options to choose from in there. But you know, it's one thing, you know, when I develop something, it's being developed according to my conventions and my knowledge. So, you know, for me to get up there and code an API and then say, here, this is how you do it, that's really not going to help any developer. So the idea behind this is we're going to cover sort of these RESTful principles. We're going to give you the ideas of, you know, a full understanding of what you need to be, or at least a pretty full understanding. And then we're going to walk through some patterns with regard to authentication, with regard to serving data and modeling data. And then, you know, the last part of the day is going to be dedicated to turning the participants loose and saying, solve this business problem, develop an API around it. And, you know, by the time you walk out of here, you're going to have a fully functional application that's been developed by you using your coding conventions that you can then use as a template to build future RESTful services for your specific business problems. So that sounds really useful, Jon. So looking at the Into the Box conference as a whole, what are you looking forward to at it? You know, I think I'm looking forward to, certainly looking forward to being able to share knowledge. I'm a big believer of the phrase, when you teach, you learn, you know, and I always find that I walk away energized from teaching as well. But at the same time, there's a lot of great sessions out there. I look forward to sharing knowledge. You know, just going to conferences like, you know, like Into the Box, like CF Objective. You know, these are all conferences where you get a chance to connect with peers and walk away re-energized about your work. And you know, as developers know, there's a lot of days where you're just slogging through lines and lines of code, and you know, some days it's not fun. But I find that the energy that I get from there also keeps me energized throughout the corresponding months when I'm working on maybe some of those things that aren't as fun. So
cool. So if folks want to reach you, how would they find you?
They can find me either at J Clausen on Twitter, J Clausen on the CFML Slack channel. They can also reach out to me via my Ortus email if they want, which is also jclausen@ortussolutions.com. Or they can visit silowebworks.com and contact me there.
Great. Well, thanks so much for being on the ColdFusion Alive podcast, Jon.
My pleasure. Thank you, Michael.